All right, we got it. All right, we ready?
I didn't even start my study guide though. That helped you.
Okay, so let's talk about slope fields. Okay, we're gonna only do one of these because eventually when we get to chapter 6, we do a whole bunch. Your book just introduces it here. But this is the reason that we can do what we just did on that last problem. Okay, the last homework problem where we had the point. And so this is the context of putting it back into the graph. Okay, so basically what a slope field is it consists of line segments with slopes given by the differential equation. Because when we just get plus c, the plus c part, we don't really know what the graph looks like, right? But we can get a good idea of what the slopes are on it. And eventually I'm going to teach you how to draw this thing. Today we're just going to go with you be able to trace the function over the top. Okay. These line segments give a visual perspective of the directions of the solutions of the differential equation. If we're given a specific point, we can draw a solution through that point. Okay. All right. So the first thing we're doing is we're supposed to sketch two approximate solutions of the differential equation on the slope field, one of which passes through the given point. Okay. And then we're going to use integration to find the particular solution of the given differential. This thing here, these words come up all the time on the AP tests, okay? I really emphasize that, okay? So particular solution means I have to solve for C, the plus C part, okay? All right, so you see how they're given a whole bunch of little slopes? That's what the slope of your graph is supposed to look like. So here's what I'm going to do to start this one, okay? I'm going to say, let me make sure I draw it the way I did last year. All right. This means those are pretty much vertical slopes, right? So it's kind of going flat and heading up. And then here it kind of slopes down. And it probably does something along those lines. Okay, yes?
How did you know that's how it worked?
Because I followed the direction of the slope. See how these slopes on these points are going up?
Oh.
This slope is flat. It kind of curves. It flattened out. There's no real right or wrong answer on here, okay? Just do the best you can, follow the guides. And then the next one should be fairly parallel to it, right? Because we're supposed to draw two, so you get to pick your own second point. Something like that. Okay? Mine are by no means perfect. Okay? All right. Now we need to do, that was part A. Okay? We need to use integration to find the particular solution. So the first thing I'm going to do is take this dx and move it to the other side, separate our variables. So dy equals x squared times x cubed minus 1 squared dx. All right, we need a U-substitution, right?
Yeah.
So what's your U going to be?
X cubed minus 1.
Good, so du is going to be... dx, and I have the x squared in the dx. I do not have the 3, so I have to move the 3 over. I'm going to put a little squiggle there. du equals x squared dx. All right, let's sub in. Throw our integral symbols on there. The dy is just going to become a y. We get u in for this part, so u squared. For the x squared dx, what are we putting in? Not 1/2. But 1/3, close. All right. Okay, when I go to integrate u squared, what do we get? U cubed over 3 plus c. I'm going to put my u in. At the same time, I'm going to multiply my 3's together. My u is x cubed minus 1 plus c. So that looking like, look at your function. It looks cubic, doesn't it? Yeah, and it looks like a wide cubic, right? The fraction is supposed to make it wider. So you're on the right track on your graphing. The other thing I haven't done yet is I have to solve for c with that point to find the particular solution. Okay? So what am I going to put in for the y? What does it say? 0 goes in for the y part. Okay, so 0 equals, and then what's going to go in for the x part? 1. All right, nice, because what's 1 minus 1? 0 over 9 plus c, so c is going to be 0. So basically I take this thing and rewrite it without the c on it. What happened? There was supposed to be a cubed on there too, wasn't there? Yeah, still the same answer. Minus 1 cubed over 9. That's your answer right there for the particular solution. And look at that. I mean, it looks like it's shifted over 1, right? For our particular solution. It shows that on the graph even. All right. That's the only one of those ones we're doing. Okay? And then we've only got, what, 2 more examples after this? Isn't that nice today, huh? All right. It scares them in BC when I only do 2 examples, so it's not that scary in here yet. All right. Right, do you have to write down on that one? Yeah, you got to write down over on this side, right? You got to put these guys in the boxes.
Yeah.
Put those in the boxes. Oh, just the second part. Sorry. Just put this part in the boxes. Okay, so let me explain the integration with the even-odd function, and then we're going to review even-odd functions really quick, okay? So an even function, typically something that's squared, right? So it looks like this is something that would be a quadratic squared. A shortcut, rather than going from negative a to a, okay, a shortcut could be, do you see how this area here and this area here match? I could just double going from 0 to a. Now I don't use the even one as much as I use the odd one, okay? But so that is a shortcut. It's still going to work if you go from negative a to a. You're just going to have to watch your signs a little bit more, okay? There are instances, though, where it's better to do the doubling of the function than it is to go from negative a to a, okay? If I have an odd function, see how these areas are the same? But this area up here would be positive and this would be negative. So what happens to a positive and a negative that are the same? They cancel, so that's why it's 0. Okay? All right, so let's check this out. We're going to do 1 even and 1 odd. Oh, I forgot to talk about even and odd. Really quick, your review on even and odd, because it's going to come up when you have a trig piece, okay? Most of them you're going to be able to tell by the exponent, right? An even number is an even, an odd number is an odd. But to tell if it's even or odd, you sub in a negative x, okay? If you get a positive of the function, it's even. And if you get a negative of the function, it's odd. If positive of function, it's even. If negative of function, it's odd. That's the sine and the cosine thing. Okay, if that comes up in the homework, which it doesn't come up here, but it might come up in the homework. I'm not moving yet. Okay. It wants us to show using the even and odd properties, so that I'm going to use them. This only works if these two numbers are the same, okay, but with opposite signs, all right? I wouldn't use U sub. I'd probably go ahead and distribute that in. So let's distribute that in and then decide if we're even or odd. So I've got x to the, what, 6th plus 2x to the 4th dx. So what type of function do I have, an even or an odd? Even. So I'm allowed to switch this. I'm allowed to double it. Let's go from 0 to 4 of x to the 6th plus 2x to the 4th dx. So that's using that property. All right, let's go ahead and integrate. So I've got 2 hanging out in front. I'll put a parentheses. X to the what? 7th over 7 plus 2x to the 5th over 5 from 0 to 4. The upside is I don't have to plug in the -4, right? Because these are pretty ugly exponents. Plugging in the zeros is just going to make it all go away, right? All right, multiplying by 2 is probably easier than putting the -4 in. All right, so let's put in the 4. Actually, we're just going to do this mostly in our calculator, right? 4 to the 7th over 7 plus 2 times 4 to the 5th over 5. And then minus 0, right? If I put 0 in, it would be 0. So I'm going to let you guys take a minute, plug it into your calculator, and tell me what you get. That's a fourth of 4. It's going to be in the thousands. So everybody plug it in right now. $192,000 is not what we got last year. What'd you get, Caesar?
5,500.
Perfect.
It's because I clicked control.
You didn't hit control divide?
Control enter.
Oh, okay. All right.
Let's do no fraction.
Yeah. So, everybody okay with 5,500?
Yeah.
All right, awesome. Let's look at the next one. So on the next one, if I distribute that in, we would get x to the what power? To the 5th plus 4x cubed. Even or odd? Odd. So when I have an odd function and I'm going from a negative value to its same positive value, what's my answer?
Wait, how'd you know it was on?
Because my exponent is odd.
Oh, shoot.
And if I didn't, that's where I would plug in the negative x, right? It should come out to be the negative of the function. Okay? If you